Hello everyone. In this video we will discuss about isotopes. So what are the isotopes? Have you heard about isotopes? If maybe somewhere in the nuclear energies, right? So what are the isotopes? So isotopes are basically atoms from the same elements. So these are basically atoms of same element. Well, if it is from the same element, then what's the difference? So the difference is they have different mass number. So have different mass number. Different mass number. Alright, so if they are atoms of same element, which means the number of protons should be the same, right? Because let's say we talk about hydrogen. Hydrogen has how many protons? Hydrogen atomic number is 1 and hydrogen has 1 proton. Hydrogen cannot have 2 protons because if it has 2 protons, let's say it has 2 protons, then it's not going to be hydrogen. It's going to be a different element altogether. So it's going to be helium. So the number of protons stays constant for every element. So for isotopes, it is the atoms of same element. Since it's atoms from the same element, so number of protons stays constant in all of the isotopes. But how can they have different mass numbers? Obviously, they're gonna have different neutrons, different number of neutrons. So remember, neutrons is also adding towards the mass number, right? So let's have a quick recap. So our mass number is equals to number of proton plus number of neutron. So what changes? In isotopes, the mass number changes and number of neutron changes. So in isotopes, these two are different. And what stays constant? Number of protons stays constant because you cannot change number of stays constant. Okay, let's do an example. So magnesium's gonna have 3 different isotopes. So let's do this one. Magnesium's. Okay, so I'm gonna write 3 isotopes of magnesium's. Magnesium's 12. So remember, what is the bottom number says? Bottom number is our atomic number. So if magnesium has 3 isotopes, all of them should have the exact same number of proton. So everything should be 12, because if you add a proton, if it's become 13, then it's not going to be magnesium anymore. What 13 is? 13 is aluminum. If you have 13 proton, then it's become aluminum. So proton is extremely important, right? So let's erase this. Okay, so magnesium has 3 isotopes. So what changes in isotopes? The number of neutrons, right? So number of neutrons or mass number. So magnesium has 1 isotope where its mass is 24. So this is the top one, is our mass number. So it's 24. Another one is 25. Another one is 26. So these are called, this is magnesium 24. You can call this magnesium 24. You can call this magnesium 25. You can call this magnesium 26. So this is how usually we name the isotopes. This is called as Mg24, Mg25, Mg26. Okay, so right now let's do a quick table. Okay, I'm gonna draw a couple of things. Okay, so let's do a quick calculations. First one, number of proton. How can we find out number of protons? Looking at the 12. So atomic number is the number of protons. So everybody gonna have 12. So it stays the same, right? Mass number, one is 24, one is 25, one is 26. So it is different. Number of neutron, so how can we find out number of neutron? So it's gonna be 24 minus 12, so it's gonna be 12. 25 minus 12, so it's gonna be 13. 26 minus 12 is gonna be 14. So 26 minus, so that's different. So we found out that all of these isotopes have different number of neutrons. Are we good so far? Can you find the electrons? Electrons does not change, right? So if the molecule is neutral, the number of proton should be equals to number of electrons. So that should not change. So it's gonna be still 12, 12, 12. So it stays the same. All right, so now we're gonna make things a little bit more complicated. How? We're gonna add a couple of different terms here. So in nature, we have three different type of magnesiums. So like if you dig up your earth and do a magnesium mining farm, and then you extract magnesiums, then you will find our nature has three different kind of magnesiums. One is Mg24, which is one isotope, Mg25, Mg26. They all exist. So the exact mass of each of isotopes is slightly different. So the exact mass of isotope, which is AMU. So Mg24 actually it's 23.99. This 125 is 24.99. Mg26 is actually 25.98. And the percent abundance, this is critical. Percent abundance. What does this mean? Let's say if I found 100 magnesium element from the earth, out of that 78.70% would be Mg24. So this is the most common one. So this is Mg24 is most abundant or most common one. Then only 10% of them are gonna be 4.99. So this is only 10.13 percentage. And only 11.17 percentage of them are going to be Mg26. So you don't have to memorize these numbers, like any of this number except the number of proton, neutron, and electron, but know that what mass of isotopes and what abundance means. All right, so let's make it a little bit more complicated now. Let's do a problem. So I'm giving you three symbols: A, B, C, X, X, 815, 715, X, 612, X, 614. Sorry, that was ugly lane. 715, 816. So which of these are isotopes? So which of these are isotopes? Which of these pairs are isotope? Definitely this cannot be isotope because these two have different proton. So those two are not isotopes. Those are not isotopes. They are from different elements. So they are different element. To be isotope, they has to be from same elements. How about this one? The same mass atomic number. So they are from different element, but they have different mass number. So these are isotopes. These two are isotopes of each other. How about this bottom one? 6, 7. So these are not isotopes because they have different proton number. If they have different proton numbers, they are from different elements. All right, I'm gonna stop right here.